Hello, 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 hello. Intercepts, critical points increasing and decreasing. Yeah. All right, so intercepts are points where the graph intersects the x or the y axis. So you should be able to figure out that the x-intercept is where y equals 0. So that's where it crosses the x-axis. Because the x-axis, that's the line y equals 0. The y-intercept occurs where x equals 0 or on the y-axis. Okay, so you could look over here. This line right here, you might want to write this down. This line right there, that's the x-axis, right? X-axis. Whoa, what's happening? I don't know what just happened. This is the x-axis. X-axis. It's also the line y equals 0. Okay, this line right here is the y-axis. You should know that. And that's the line x equals 0. Okay? Now, so we have to identify the x and the y-intercepts of the function below. And I skipped ahead of myself. So to find the x-intercepts, let's just look at that line right there. It crosses right there, which is the point, something, 4, 0. Y-intercepts, where it crosses the y-axis, that point right there, which is 0, 2. Cool. Let's look at this next one. So it's where it crosses, we have 4 different x-intercepts here. So we have negative 1, 0, 1, 0, 2, 0, 3, 0. The y-intercept is just 0, 5. And you will always only have one y-intercept. If it crosses the y-axis more than once, it's not a function. Okay, you can have as many x-intercepts as you want. We could have hundreds and hundreds if we wanted, like in a sine wave or something. But y-intercepts, you can only have one. Okay, this next one, there's no x-intercepts. And we have a y-intercept there at 0, 5. Cool? Okay, let's look at this. So to find the zeros, you set f of x equal to 0 and solve for x. That's how you find the zeros. To find the x or the y-intercept, you find f of 0. So zeros, this is the same. There are a couple different words for zeros. That could be roots. That could be x-intercepts, intercepts, zeros. What is happening? Why does it do that? Roots, x-intercepts, zeros. Sorry, struggling really bad right now. But let's go through this. So let's look through A. Possibly, maybe. Yeah. Okay, so we're going to find the zeros first. So we're going to set f of x equal to 0 and solve for x. So I just plugged in a 0 where that f of x is. And I'm going to solve this for x. So I'm going to subtract that 3 over. You get negative 3 equals negative absolute value of x minus 5. Divide by that negative 1, so you get 3 equals the absolute value of x minus 5. Now, we haven't gone over absolute values yet this year, but basically, whenever you have an absolute value, you have to set it equal to the positive, and you have to set it equal to the negative. So we're going to have x minus 5 equals 3, and x minus 5 equals negative 3. And then we're just going to solve both of these for x. So I'm going to add that 5 over, you get x equals 8. Add the 5 over, you get x equals 2. So my zeros are 2, 0, and 8, 0. Now for my y-intercept, I'm going to plug 0 in for x. So I get negative, absolute value of negative 5 equals 3. Well, the absolute value of negative 5 is 5. So that's going to be negative 5 plus 3, which is negative 2. So my y-intercept here is 0, negative 2. Cool? Let's look at this one. So first we're going to find the zeros. We're going to set it equal to 0. And we're going to factor this. We have to factor it using slip inside. So that's going to be x squared minus 7x minus 8, which is x minus 8, x plus 1. Divide those by 2, and you get x minus 4 and 2x plus 1. And then we're going to set both of those equal to 0. So we have x minus 4 equals 0, 2x plus 1 equals 0, so x equals 4, and x equals negative 1/2 after you solve those. Okay, so those are my zeros. Now I'm going to find my y-intercept, plug in 0, and you get negative 4. So my y-intercept is 0, negative 4. Cool? You can do example C. Remember, take out the GCF first. You should get zeros as 0, 0, negative 5, 0, and 2/3 0. And then the y-intercept is 0, 0. Okay, you can do D also. The zeros are 3, 0, and the y-intercept is 0, negative 1. Okay, let's look at this. So critical points are where the graph changes its direction or its shape. So extrema, there's a bunch of different pronunciations. I honestly don't know what's right. So I'm just going to say extrema, are points where the graph changes direction. So like, say you're going up, and then you go down. So the function has a minimum and a maximum, and they're relative and absolute at these points. Relative means it's not so if it's a relative maximum, it's not the highest point on the graph, but it's the highest point compared to the points directly around it. Absolute means it's the very highest point on the graph. Okay? And then a point of inflection is where the graph changes its shape, but it doesn't change its direction. So it's like, it's still going down, it just kind of changed a little bit, and then it just keeps going down. Okay? So the relative maximum is a point with the greatest value compared to the points around it. It's also called the local maximum. Absolute is the greatest point over the entire domain. Now, relative minimum is the point with the least value compared to the ones around it, so it's the smallest comparatively to the ones around it. Then absolute is the very smallest point. Okay? Now let's look at this. So given the coordinates, classify the extrema, blah, blah, blah. Use a graphing calculator. So a graphing calculator is needed for this. Now first, that's an absolute minimum at the bottom right here, this point right there. There's no points lower than that on this graph. Now, maybe, I'm going to show you, that is 4, negative 5. And you can just look at that by looking at the graph. Okay, sometimes the graph doesn't work though. So I want you to pull out your calculator if you have one and go through this with me. So first you're going to click y equals, this is the top left. Then you're going to plug that equation in, so 2x squared minus 16x plus 27, then click graph. And you should get that right there, which is the same graph that we have up on the top. And if it doesn't look like that, click zoom 6 and it'll get to this point. Zoom 6 is usually, that's your standard window. It'll just put it back to standard. Okay? Now to find the extrema, you're going to push second trace, then you're going to go to minimum, since this is a minimum. Okay? And then for the left down, that spider looking little buddy, we're going to put him to the left of our minimum. So on this one right here, you could see our little spider buddy right there. So, and then you're going to click enter once it's right there. Then you're going to do the same for the right bound right there. Click enter, and then click enter one more time. And it will give you that minimum right there of 4, negative 5. Okay? Now, for example B, we have an absolute max, we have a relative min, and we have a relative maximum here. And the absolute max is negative 1.5, 2.9. Relative min is 0.3, negative 4.3. Relative max is 1.3 and negative 2.7. And I guess I did not do that one in the calculator. So if you need me to, I will go over a couple more of these in your calculators, or like individually. I don't think we need to do this as a class, but just ask me in class if the whole calculator thing is confusing, okay? And then this one, we have a relative min and a relative max. So we're just going to put it in our calculator, find those with there, and you should get negative 3, negative 5, negative 0.3, 4.5. Cool? Okay. Now, this is the last thing we're going to do for this video. Increasing, decreasing, and then constant. So increasing is basically, think of a mountain. Okay, I like climbing mountains. I don't know if you guys do, but that's what I think of. So when I'm walking up a hill or walking up a mountain, I'm increasing over that interval. Okay, so when you're walking uphill, if you're going from left to right, when you're walking uphill, that's increasing. So this is increasing from negative infinity, because we have that arrow, clear up to negative 1. Then up at the top, we're just walking on a flat surface. So that's from negative 1 to 4, that's constant. And then it's decreasing, I'm walking back down from 4 to infinity. Okay? Let's look at example A. So this is increasing from 3 to infinity because it's not increasing from negative infinity to 3. I'm actually walking downhill right there. So you're only going from 3 to infinity. Decreasing is negative infinity to 3. On this next one, you're never increasing here. We're always decreasing. But there's that one point where there's nothing equal there. So it's going to be from negative infinity to negative 5, and then from negative 5 to infinity. The last one, we are always increasing, so it's negative infinity to positive infinity, and it's never decreasing. Cool, we're going to skip those next examples. Remember to take the quiz. You guys rock. Goodbye.